Welcome to the tutorial about calibration data analysis using Python. Well, this tutorial is mostly aimed at calibration and test engineers who have to deal with a huge amounts of data. So currently, most of the engineers do it manually by using the tools such as MDA or ATI Vision. And the aim of of this presentation is to show that there is a better way to analyze a big chunk of data without actually looking at the data by the use of basic computer programming. And that's the whole theme of the presentations. So before we talk further, we need to understand what's the role of data in automotive industry. So in today's time, data is even more valuable than gold, and especially in the field of IT, it's no one has to give an explanation of how important is data. But also in our automobiles, like with the growing complexity of the cars, lots of ECUs are getting strapped on the cars, and they come with ever increasing complex functions. What this means is that you have a lot of data being generated as a result. Now, as engineers, it presents unique challenges because then you need to, in terms of making, you need to make the right decisions within a given amount of time. And your quality of decision making depends on striking the right balance between quality and speed of data processing and the time at hand. So mostly, if you get a lot of data and you have to analyze it in a short amount of time, there are good chances that your quality of data analysis will go down. So the future belongs to the engineers who are able to adapt themselves to the rapidly changing needs, not relying on only on industry standard tools, but also learning a little bit of computer programming to solve this problem. And we will see how. So currently in the industry, there are two common tools like ETAS MDA and ATI Vision to analyze the measurement data. So the engineer goes out in the car, collects the data, and then he gets this big DAT file, which he looks through in these tools. Of course, it depends whether you are using Inca or you are using ATI Vision. But nevertheless, both of them are great, provide their own measurement data analyzers, and they're quite good when you need to analyze multiple signals, which are plotted as a function of time. And this is good when you have a limited number of files. And these tools also give you some more additional functions. For example, you can perform additional mathematical operations on the recorded signals. So you can recreate new signals. You can export data in different formats. You can compare multiple files, and you can do some extra plots like scatter plots, etc. This is a screen grab of how the ETAS MDA looks like. So you generally get a file explorer where you can select a bunch of files. Then in the signal explorer, you can get all your signals, which you drag and drop in and create this oscilloscope. And then you can more or less arrange the signals into different oscilloscopes depending on your needs. You can create different layers for different types of signal and or analysis that you plan to do. There are also options to calculate extra signals, and there are some configuration options. And this is pretty much the industry standard. And this works pretty good because this helps you to analyze data in great detail. But there are certain limitations. This kind of analysis is mostly manual, and you do one file at a time. It is also time consuming because let's say if you have to analyze emission data, emission tests from 20 different cars in a given time, then this kind of process is quite time consuming. And, and if there is this time pressure where you have to analyze a lot of files in a given amount of time, then it will be prone to errors. So, and, and these are really good for complex analysis, which we will show in one of the use cases. And there are also limitations that you can do only so much, that there is a limited coverage. So how do we solve this problem? So a good way to solve this problem is by bringing in automation. What if you could automate the entire process so you don't have to look at data at all? There should be some imaginary stuff that can just go through your files, read all the data, and just throw out the result in some format that would be more intelligible to you. And this has advantages. You can do quicker and deeper data analysis, and you can also get a high degree of accuracy. And this is a win-win situation for both the engineers, who can then spend their time on doing more useful work, as well as for the organization, because it saves tons of money and also gives better quality. So how do we go about this? Of course, large-scale automation means you need to do something with the computers, and that's precisely how it's done. We can do this by scripting, and this means that writing computer programs. So there are small computer programs that you can write very easily, that can more or less look through all your files and then give you the results that you need. And to do this computer programming, there are generally two different scripting languages. One is MATLAB and Python. Out of MATLAB and Python, we think that Python is good. It's recommended for use because it is free, light, fast, and it has a host of libraries for doing a lot of data analysis, plotting, mathematical calculation, you name it, they have it. So let's look at one of the use cases where this can be useful. So over here, I've just taken a plot from OBD data, which is obtained in MF4 format and plotted in Python. So we have got vehicle speed in blue, we've got engine speed in green, and we have got the throttle position in yellow. Now, our objective is to find the intake manifold pressure when engine speed is greater than 2500, throttle position is greater than 30, and vehicle speed is greater than 20. And for what percentage of time the above condition is true. Now, manually, it is quite difficult task to analyze all three conditions at once. Yes, you can do it, but it will take a lot of time and it will provide you limited coverage, and there will be a lot of chances of errors or missing out on analysis. But if I write a simple computer program to filter out all these conditions and plot the intake manifold pressure, this is how the result looks like. So here we have filtered the engine speed greater than 2500 rpm, throttle position greater than 30, and vehicle speed greater than 20 kph. And this is the plot of intake manifold pressure as a function of time. So you can precisely see at what times your conditions were satisfied. And at the same time, we can see the percentage of time the above condition has been true. Now just imagine if this is a very simple case that everyone has to analyze. What if there are several of these kind of conditions that you need for your analysis, for your calibration work, and you have to do this kind of analysis over 100 or 1000 files? Then you can understand the complexity of the situation. And this is where your data analysis tools like Python, they can just read almost a gigabyte of file in 1 second or 2 seconds, and then do this analysis and just plot the results. You can also combine several files and make them into one big file and then do the analysis on that. So it's a really cool stuff that that can be performed with Python. Use case two. So the first one was regarding just simple data analysis. Uh, Other option is also you can model lots of mathematical stuff in that. For example, let's say we had a given vehicle configuration, vehicle mass, coefficient of drag, rolling resistance, etc. And we want to design an electrical car, and we want to find what should be the size of the motor. So most of the people are quite familiar with the basic road load equations, where you combine the aerodynamic force, rolling resistance, inertia force, and then add them up to get the net demand. And then you multiply the force by velocity to get the power demand. And let's do it over the net C cycle. So here you can quite easily write the inputs, connect them with some sort of equations, and then you get results on the output. And this is quite easy to perform, and you can change your input condition several times and get the outputs. And you can automatically store the outputs if you want to do some filtering of the results. Okay, what would be my power demand between 800 to 1000 seconds on the net C cycle? You can easily get all the snaps depending on how you customize it. So in further use cases, we have automatic analysis and reporting of emission cycle and engine testbed data. So the engineers, they can easily script the computer programs, and that could be aimed towards reading multiple files from different emission tests, or also files from engine test beds, and then just putting out the results in some kind of understandable format in some folder. Then the second one is the optimization of calibration functions. I mean, you can find better ways to calibrate your functions since you have a better control of the analysis of the boundary conditions, and you can also use curve fitting tools, etc., to find better fits for your maps and tables. Then you can recreate the Inca data with additional signals, and then you can increase the analysis capability of the team. By this, what I mean is that let's say you are calibrating the hybrid strategy of the car, and then you need to understand what is the BSFC that the current system is running at. And then you can easily recreate the BSFC or some other hybrid calibration related parameter, and then store them in the DAT file. This is because there won't be everyone who would be good with Python. So then it's and certain things are quite good to do in MDA. So this can help to create that extra signals, which can be further analyzed in MDA in great detail. And then we have the automatic analysis and reporting of several GBs of expedition data. So let's say you go on an expedition, you get 1,000 different files from different cars, and then you need to do certain analysis, and generally it happens like all the team have their specific needs generally when they go on expeditions, at least in terms of transport data. So then you can just write a script which collates the information from everyone, XYZ requirements, and then just run the script over all the files, and then you can process and do all the automatic plotting. It's also quite good in doing hybrid strategy optimization, which is actually quite complex to do manually. And there are many more things that you can do with it. There are just endless opportunities. How can we help? From our part, we would like to help by providing a series of video lectures which are mostly aimed at teaching techniques related to data reading and manipulation in Python. With that, we mean that we will be teaching the techniques. Let's say you have a inca.dat file. So first step is how to read that in Python. And then once you have it in Python, then how do you go about doing several kind of analysis? And then this doesn't need any kind of prior knowledge of Python. The idea is not to teach Python, but just to teach the elements of Python that would be helpful in the analysis of data. And this is actually pretty easy to do. And then there will be further video examples on certain different use cases regarding optimization and modeling related stuff. And this can also be catered on demand. If you have a certain need that you would like to see how that can be done in Python, we can try to help you with that. And the target audience is all the calibration and analysis engineers with or without programming background, because it's always a misconception that the mechanical engineers cannot do programming and that's only reserved for computer engineers. But here we try to solve that problem by trying to make this tutorial easy to follow, so that everyone can reap the benefits of it. And even in best case situation, not everyone would be able to learn this, but we try to make it as easy as possible so that maximum people can at least use it. So yeah, that was all. If you have any further question, please do not hesitate to contact us. Thank you.